In this video, as you can see, we're going to do a bunch more examples, and this is actually going to be our penultimate video for this week. We'll have one more where I want to do just 2 more examples with you, and then it'll be it for this week. One thing you'll notice is that when it's faster to construct a new sign chart, it doesn't take very long at all to solve the inequality. So although it looks like, oh my goodness, we have 8 examples here, actually I guess we have 7. It doesn't take very long to do them. So look, for the first one, solve this inequality. X minus 3 times x plus 5 times x minus 7 is less than or equal to 0. We start by observing we have no non-negative factors. Okay, and our critical numbers are, you can say them with me, 3, -5, and 7. Okay, let's plot them on the sign chart. So -5 is leftmost, then 3, then 7. It's all about going in increasing order along the number line. And then pick a test point. I really want to stress this notion that the test point can be anything that's not a critical number. So I'm just going to go to town and pick one at random. So I'm going to pick 5. No reason. I just want to really stress that you can pick anything as a test point as long as it's not a critical number. Okay, so 5. Incidentally, already make a mental note. 5 lives in this third region from the left between 3 and 7. And now we're going to plug 5 into each of the pieces to see what we end up with. So plug 5 into x minus 3, you get a positive value. Plug 5 into x plus 5, you get a positive value. Plug 5 into x minus 7, you get a negative. Positive times negative is negative. As we said, 5 lives between 3 and 7. So we put a minus sign over this region. And then since there are no non-negative factors, the sign changes around each one. Okay? So now let's go back to the inequality, right? So we want to be less than or equal to 0. So that means negative or equal to 0. Okay. So let's look at what parts of our sign chart do we see a minus. We have one here, and we have one here. And since being equal to 0 is fine, we can include the -5, we can include the 3, and we can include the 7. If you're in doubt, like, oh, I find it confusing whether to include the endpoints or not, one thing you can do, and you'll only need to do it a time or 2, is take the endpoint and plug it into the inequality and see if it's satisfied. For example, if I plug -5 in for x up top, I get -8 times 0 times -12. Boom, there's a 0 in there. The whole product is 0. Is being equal to 0 okay? Yes. So -5 is part of the solution, so it's included. And that is a quick check, and it gives you a moment to sort of ground yourself and go back to, okay, what am I actually doing here? So that quickly, we have the solution set. We have all real numbers from -infinity to -5, union the real numbers between 3 and 7. Okay, so now let's look at this little quadruplet of examples. I hope that you've noticed, but if not, let me draw your attention to the fact that it's the same expression in all 4 examples, x squared times x plus 3. And I'm asking you, when is that greater than or equal to 0, less than or equal to 0, greater than 0, or less than 0. So what's really important here, and I tried to sort of show this with the design that I made with writing this up, we only need one sign chart. So we're going to put our sign chart here, and then how we read that sign chart is going to be different for the 4 examples. Let's go ahead and do the sign chart first, and then we'll talk through the inequalities. So first things first, we have a non-negative factor. X squared is non-negative. This is big, right? So I'm going to get out my yellow highlighter. That's how I've been indicating this before. So x squared is a non-negative factor, so that's going to be really important. The critical numbers, well, there's only 2 of them. X squared is 0 when x is 0. X plus 3 is 0 when x is negative 3. And again, 0 is incredibly special here because it comes from a non-negative factor. So when we go to build the sign chart, again, pay attention to order. Negative 3 is on the left, 0 is on the right. Once again, I'm going to highlight that 0 because once again, I want to make sure that you see that is the critical number that came from x squared, so there's not going to be a change in sign. For the test point, like I've always said, use anything you want. Heck, let's use 1. We're plugging 1 in for x. When you plug 1 into x squared, you get a positive. When you plug 1 into x plus 3, you also get a positive. Where does 1 live? 1 lives to the right of 0, so here. So that means that over the region that's to the right of 0, we put a plus sign. Now, 0 came from a non-negative factor. So that means that there's not going to be a change in sign around the 0. So whatever it was to the right of 0, that's also what it's going to be to the left. However, negative 3 did not come from a non-negative factor, so there will be a change of sign around the negative 3. So since it was positive to the right of negative 3, it'll be negative to the left. We're done with the sign chart. For the rest of this problem, we're just reading the sign chart based on what the different inequalities ask. So first example, greater than or equal to 0. We've talked through this a number of times. Greater than or equal to 0 means positive or 0. So let's see, where are we positive? We are positive here between negative 3 and 0, and we're positive after 0. Notice that we don't need to skip 0 because being equal to 0 is okay. And when you plug 0 in for x, you get 0 because you have 0 times 3. So in this case, negative 3 will be included because when you plug negative 3 in for x, you will get 0 as the product. And then you don't need to write anything more. The solution to the first inequality in the top left is just all real numbers from negative 3 to infinity. Okay? All right, next. So what I'm going to do now is I'm going to erase my sign chart because I'm going to write it again. Okay? So sign chart, my critical numbers were negative 3 and 0. Positive, positive, negative. And again, I want us to keep remembering 0 came from a non-negative factor, which is why it doesn't have a change of sign around it. Okay, let's look at the top right-hand inequality. We want x squared times x plus 3 to be less than or equal to 0. Less than or equal to 0 means negative or equal to 0. Okay, well, we're negative here to the left of negative 3, but then we also want to allow being equal to 0. So we will include the negative 3. And since the expression is also equal to 0 when x is 0, we also include 0. So here we are. The solution set is all real numbers from negative infinity to negative 3, and also the number 0. Okay? All right. 2 more, and I think you'll notice they also go pretty quickly. I'm going to rewrite the sign chart one more time. One thing I challenge you to do, maybe while I'm rewriting the sign chart again, see if maybe you can work out the solutions to the other 2 inequalities on your own time, just right now. It's quite a challenge, but maybe you can do it. Okay, so here is our sign chart again. Let's look at the bottom left-hand inequality. So here we want x squared times x plus 3 to be strictly greater than 0. So that means strictly positive, being equal to 0, is not allowed. So we're kind of back to the conversation that we were having in the first example, except since being equal to 0 is not allowed, we're going to go between negative 3 and 0. But then we have to skip around 0. We do not include the 0 itself, so there's a break there. Similarly, we do not include the negative 3. So like this. Okay. Also, if you'd like, if you don't want to kind of back-to-back parentheses like this, you can also put an empty circle there to indicate that you're skipping over the 0. So the solution set here is negative 3 to 0, skip the 0, and then from 0 to infinity. So remember, in interval notation, we indicate that we're skipping a value by using parentheses. Okay, good. For our last example, same sign chart, reading it differently. So we want to know, where is x squared times x plus 3 strictly less than 0? Again, just while I'm rewriting the sign chart one more time, see if you can quickly jot down the solution to this inequality. So we want to be strictly less than 0. So that's strictly negative. Well, where is this expression negative? Looking at the sign chart, it's to the left of negative 3. Since being equal to 0 is excluded, we indicate that with parentheses around the negative 3. And we don't need to do anything special around 0 unless we go to extra special means to include the 0 here. It isn't included, left up to its own devices. So the solution set to this inequality is simply from negative infinity up to negative 3. All right, so good. Let's move on to the next example. So with this next example, we have a quotient. I promised you that we would do an example with a quotient. X minus 8 over x plus 3 is greater than or equal to 0. I have said time and time again, let me say one more time. For sign chart construction purposes, products and quotients are identical. We want to be a little more careful with reading the sign chart and stating the solution set to the inequality with quotients, but as far as sign charts are concerned, exactly the same process. There are no non-negative components here. Okay. The critical numbers, looking at the numerator, we have 8. Looking at the denominator, we have negative 3. Looking at the number line, negative 3 is to the left, 8 is to the right. Use any test point you want. So let me go back to my familiar roots. I love using 0 as a test point when possible. If you plug 0 in for x, the numerator is negative. If you plug 0 in for x, the denominator is positive. Negative divided by positive is negative. Where does 0 live? Say it with me. 0 lives between -3 and 8 in this middle region. So we put a minus sign between -3 and 8. Since there are no non-negative factors, the sign switches around both critical numbers. There's our sign chart. Now let's look at our inequality. The inequality is asking us, when is this expression greater than or equal to 0? That's positive or equal to 0. I will write that at the risk of things getting a little claustrophobic. All right, so let's look here. Where is this expression positive? It's positive when x is to the left of -3 and when x is to the right of 8. But, so here is the distinction between quotients and products. You can't divide by 0. So the critical number that comes from the denominator is not admissible as part of the solution because division by 0 is undefined. So even though it's a non-strict inequality, we still do not take -3 into our solution set because at -3 the denominator is 0. However, we do take 8 into our solution set, so we put a nice bracket there. And so there's our solution set. All real numbers to the left of -3. So that's from -infinity to -3, but not including -3. And then all the real numbers from 8 onward. All right, so be careful with that interval notation piece. What I wanted to show you here is I actually wanted to pull up this problem in WebAssign, and I have it here. So this is homework 4, problem 1. Okay, and what I wanted to show you, let me just activate my Wi-Fi here. What I wanted to show you is how to use the grapher tool. So you have this grapher tool, and we want to show that we want to take everything up to -3, not including -3. You can see that you can choose open circle, closed circle, parentheses, and brackets. I personally like to choose parentheses here, but you can use an open circle to indicate that you're not including. We're then going to put it at -3. Okay? To show that you're also taking everything to the left of -3, we're going to use the pencil tool and we're going to mark what's to the left of -3. We also want to take everything to the right of 8, including the 8. So we're going to put a bracket on the 8 there, and then we're going to shade everything to the right of 8 like so. So that is how you use the grapher tool in WebAssign. Sometimes it's a little confusing. If you find yourself confused by it, by all means, feel free to ask during our question answer session. Okay, back to our lesson here. So we have one more example to work through. And this example, I almost want to talk through the beginnings of it and then let you think about the rest on your own. But in this example, you'll notice that the inequality is not set to 0. Neither one of the sides is 0. It's very tempting, and I'm even going to write this in orange, which is kind of my caution color. Tempting. Multiply both sides by x plus 4. X minus 4. This is tempting for a whole variety of reasons. It's kind of what feels familiar. It's what we do with equations. But here's the rub. Remember, inequalities and equations overlap in so many places. But inequalities have an issue with multiplication by negatives. We talked a little bit about why that issue arises. If you have questions, ask me, I'll explain more. But the thing with x minus 4 is that it's a variable expression. you don't know whether x minus 4 is positive or negative. In fact, you do know it's positive sometimes and it's negative other times. So you can't multiply both sides by x minus 4 in the free and clear. You could, and I'm not going to encourage this or teach this, but you could set up two cases, one for when x minus 4 is positive, one for x minus 4 being negative, and solve the inequality in those two cases. I do not recommend that for a myriad reasons. If you want to talk about why, we can. To avoid this pitfall of not knowing whether x minus 4 is positive or negative, or rather knowing that x minus 4 is negative sometimes and positive other times, what we're going to take as our first step is we're going to start by setting to 0. It doesn't matter which side you set to 0. I'm going to choose to set the left-hand side to 0 by adding 4 to both sides. But you could have just as easily moved the other piece to the right, or I should say to the left. So we end up with 0 is less than x plus 3 over x minus 4 plus 4. From here, we're going to do a cleanup step. And by cleanup, what I mean is put everything over a common denominator. Okay, so I'm going to write that in parentheses here. You're going to put everything over a common denominator. And for that, many of you will find it useful to think of this 4 as 4 divided by 1. Okay, so I'm going to rewrite here to have a little bit more room. And to make that 4 over 1 have the same denominator, I'm going to multiply it top and bottom by x plus 4. So what I end up with is, on the top, x plus 3 plus 4 times x plus 4. And on the bottom, I've made them so they have the same denominator, which is x plus 4. Opening up and combining like terms, on the top I end up with x plus 3 plus 4x plus 16, which is 5x plus 19, over x plus 4. And I'm actually going to mostly stop here because I think you guys can see this example through to the end. Feel free to ask me questions on Friday if you have questions about how you see this through to the end. But the only thing I will say to you is, remember, inequality isn't transitive. So if you want to write this inequality in a more familiar format with sort of the algebraic expression on the left and 0 on the right, how do we read this inequality starting with the algebraic expression? So in other words, you're reading the symbol this way, right to left. And right to left, this says greater than 0. So we end up with 5x plus 19 over x plus 4 is greater than 0. And I'm going to say here, finish on your own. If you get stuck or if any part of this is unclear, bring me questions on Friday. That's all I have for you for this time. One more lesson this week. See you soon. Bye.